let's keep going. I'm going to use the internet on the phone to show a demo later on. So that's me, born in Argentina. I've been living for the last 18 years in the UK. A mixed background between marketing, technology, and lately, so as we know, we founded Leapside, and as part of Leapside, we created Bondy's technology that I want to show today. So the problem that we were trying to solve is hopefully a problem that it will resonate with you, and is that creating distributed applications, and by that I mean connecting mobiles, devices, web applications, microservices, macroservices together, is still really, really hard. So if we start with the simple problem of I want all these different devices and applications to connect to my backend, and my backend can be a combination of different things, that is important bits that we are working on as developers, right? That is the business logic, that is where the business lies. Everything else is accidental complexity, right? And the way it was going when we started with Bondy like 5 or 6 years ago was something like this. So we need to use multiple communication patterns, right? We need to use RPC and PubSub. We need to support multiple platforms up to the point that you might need to run some software embedded in a device. There are some limitations in transport options that you might have. You might need multiple programming languages, and you end up with multiple protocols, right? You possibly use HTTP and REST for the web application because that's what the web team would like to do, and that's what they're used to do. But then maybe the microservices guys will like to use gRPC for inter-service communication. You might use AMQP, RabbitMQ, Kafka. If you want to connect devices, you end up using MQTT because why not? And then you need to do authentication and authorization, right? And the challenge is you need to do authentication and authorization across all these different protocols and across all these different middleware. And then you need to do service discovery, so why don't we drop a service mesh on it? And so we end up with something like this, right? So we end up with an API gateway that doesn't care about MQTT, only HTTP. And I can then translate the JSON HTTP things that we do on the web to communicate with our backend. We end up dropping a service mesh. And by the way, I don't know if you follow this one, but you know these guys have been talking about using the sidecar pattern for about 10 years, and the same guys that were proposing that now they're saying that was wrong. So let's go to the kernel, right? So let's use eBPF. So I cannot run on a Mac now, all these things, because I need the Linux kernel. So all of that stuff is not really required. And what I want to do is just to build an application, right? And that works. So there are two patterns out there, or two solutions that the market is offering at the moment. One is what I call the API wrapper, right? And one example is Dapper.io. So basically, this actually is just sweeping everything under the rug. So you still have all of these things, but you put an HTTP API on top. So everybody speaks HTTP. Not sure that is a good thing, right? But then you still need to manage all the complexity, right? The developer doesn't know the complexity is there, but then somebody needs to run Kafka underneath, or RabbitMQ underneath, or a service mesh. And in the case of Dapper, for example, you will still need to use the sidecar pattern. The other option is just adopt a framework. So you can go Akka, Calyx, Axon. But then that is language specific most of the time, right? And then you end up with different protocols between north-south and east-west traffic, right? So you will tend to use HTTP here, maybe WebSockets, but then you will use gRPC or whatever the framework provides for the services. So you're not using the same language. And I'm afraid that after years of doing these, I conclude that the software industry is doomed to continuously create accidental complexity, and there's no way we can escape this. And yet I am here introducing something else, right? But the whole idea is, well, if you introduce something else, we need to take out something in the stack, because the way currently this cycle works is by adding layers on top of layers and without removing anything. So we came out with a different approach initially. And we thought, the way to solve this is not at the API level, is not at the language level, is at the protocol level, right? In a language and in framework agnostic way. So if I get rid of all the protocols, right, and hopefully have one protocol, then I get rid of all the middleware. And that's the hypothesis that we started with. And we said, why can't we have one protocol that I can use to communicate all these different devices and applications? And what about that protocol being peer-to-peer in the programming model sense, right? Why can't a web browser speak to another web browser? Why can't a server speak to a web browser? Why can't a web browser be an RPC server, right? I don't need HTTP and a web server to become an RPC server, but that's what gRPC and HTTP forces us to think of. So what we wanted was multiple communication patterns, primarily RPC and PubSub supported, programming language agnostic, a peer-to-peer programming model, software real-time, bidirectional. I need to have choice of transports, right? So depending on the device, I might not be able to use TCP, I might want to use WebSockets. Choice of serialization as well to facilitate the implementation and adoption of this protocol. It needs to provide security, multi-tenancy, and needs to be scalable and always on. So we started with this idea and we started creating a protocol that we call WAMP, the Real-Time Application Messaging Protocol. And I was Googling WAMP just because I thought, that's a cool name. And I stumbled upon WAMP, the Web Application Messaging Protocol. And actually, WAMP is a protocol created by Tobias Oberstein here in Germany. And they've implemented most of the things that we wanted, right? So it's basically an open standard for software real-time message exchange that combines remote procedure calls, PubSub, and authentication. So basically, we could solve the problem, but there was one remaining thing that the implementation of WAMP couldn't do, and that is scale and be scalable and always on. So their implementation was not, you couldn't cluster the implementation that they have. So that's why we started Bondy. So what is Bondy? Bondy is an application networking platform that allows everything to talk using a single universal protocol, and that is WAMP. But we want to go beyond WAMP, and you're gonna see more or less what we're trying to do. So with Bondy, I can have a single binary that is a router in the WAMP parlance that I can cluster, and I can scale out and scale up, and everything can be connected either through WebSockets or TCP. So it obviously inherits all the benefits of WAMP, but it is also scalable and always on, and we have a bunch of additional features. So another way of representing the mess that we were in is the one on the left-hand side. So we're moving from all of these different components and different protocols to a single component in your infrastructure and a single protocol plus a single library in all the devices. I don't need an HTTP client and an MQP or a Kafka client. I need a single WAMP client to do all of that at the same time. So I'm going to show you a demo, and this demo I'm going to go and switch between the demo and some slides for you to understand a little bit about WAMP. Otherwise, if I do a primer on WAMP, it's going to be too boring. So I'm going to start mixing around, and hopefully everything will work because we're using 5G here. So what we have is this application that we build. So we have Bondy being deployed on Fly.io in all of these locations. So I have basically 1, 2, 3, 4, 5, 6, 7, 8, 10 locations, and I have 2 Bondy nodes on each one, all of them connected in full mesh, right? I have a web application that I'm going to show you later that is a marketplace, and in that marketplace I can sell items, and I'm going to run bots. The bots are written in Python, the market is written in Python, the web app is using Vue.js, right? They're both using a client called Autobahn created by the same guys who created WAMP that is available in JavaScript, in C, and in Python. So all of these applications will connect to the same realm. I'm going to explain what a realm is. They will authenticate using CryptoSign, which is one of the options that you may choose to use. And as soon as I list an item, the bots are going to start working and they're going to bid. And when I list an item, I'm going to use RPC to talk to the market. And these are the RPCs that the market offers. But also the market publishes 2 topics. So the bots will listen to the topics, the application will listen to the topics to know when there is a new item on the market so that the bot can bid, and obviously the application can show the item and show the new prices coming in for every bid. So let's start with that. And hopefully it works. See if I'm connected. And it's not working. Let's check here. It would be nice if I'm connected to my network. Sorry about that. There we go. Yeah. Refresh. Oh, it should be connected. Yeah. So what we have there is, I did an RPC with that click of a button, and I created all these items that I'm selling, and I have 50 bots across the world, each one connected to their local Bondy instance. All the Bondy instances connected in full mesh. And there's a single market in London right now handling all of these communications. So basically the 50 bots are routing their RPCs and pub subs through Bondy to a single market instance in London. So let's keep it running, and we're going to go and explain a little bit more how it works. So in WAMP, you have this idea of isolation using realms, or otherwise called namespaces. So in Bondy, you can create multiple namespaces. These are logical. It's not like in MQTT mount points that you need a port. This is completely logical. So the limit to the number of realms is the limit in your hardware memory. So we have a Bondy master realm, that is the admin realm that allows you to control Bondy. And in this case, we have the com market demo realm. So every client that connects, it can only attach to a single realm. And once it's attached to the realm, it can only communicate with other peers in the realm. And it can only see messages that are within the realm. Now, every client in WAMP can be any type, can play different roles. It can be a caller, so the one calling an RPC. It can be a callee, or the server side of an RPC, a subscriber or a publisher. But actually, they can do all of that at the same time, and it's completely dynamic. So I can just spawn an application and say, I want to become a caller. Or I be a callee, and I'm going to show you later on. I'm going to just dynamically set up a new function, a new procedure in this network, and everybody else will be able to call it. There is no YAML. There is no thing that you need to deploy. Everything is controlled by your application. So the way you connect, this is a case of Python that we're using, for example. So we're connecting to a particular URL that is listening. Bond is listening on that URL. You connect to the realm, and you authenticate, in this case, using CryptoSign. So basically, I have a pair of keys. Bondy knows beforehand that this user exists because you need to provision the user in Bondy with a public key, and then the user, in this case, a username, is going to use that public key to authenticate and say, hey, I want a session, and Bondy will challenge you, right? It will send some data that I need to sign using my private key, so that Bondy recognizes and validates that this is who I am. You know, I'm the same person that Bondy knows. Apart from these, you're going to see that there are other options. So you can use password, you can use ticket, and different types of authentication. So again, in router RPC, pops up, you already know. So a publisher publishes a message to the broker. So the router in WAMP has two faces. So it is a broker, as in with similar to RabbitMQ, but it's also a dealer of routed RPCs. And the way RPCs are implemented are completely different to everything else. In traditional RPCs, you know the IP address that you're calling. You're calling a server, and that is the level of granularity that you work with, right? So I'm calling a server, and there is a path, if it is HTTP or gRPC, there is a path in that server that provides the procedure that I want. In WAMP, that is not the case. And in WAMP, everything is a function named, right? And somebody registered the function in the router, and then I can call that function. Anybody with the rights and with the permissions granted can call that function. So in the case of router RPC, a caller can call. The dealer will transform that message into an invocation to the callee who is providing the function. The callee will yield the result or the error, and the dealer will then forward the result or the error to the caller, right? So WAMP URIs, again, everything in WAMP is as in the RPC procedures or PubSub topics, and even errors are URIs. And you can do exact matching, prefix matching, or WARCA matching while subscribing, but also with RPC. So I can say I want to call com foo bar, but then on the other side you have somebody who said, I tackled everything starting with com foo, right? So all the functions that come before, after com foo, I handle those. Again, the way it works very quickly. A subscriber will subscribe with the router acting as a broker. You get a subscriber error, then you can unsubscribe. And you do that with a single line of code in your programming language, right? Again, no YAMLs, no external configurations. Is your application who is configuring this in real time. When the publisher publishes, it will get a publish or error, and then that will generate an event that is broadcasted to all the subscribers. Again, to publish just one single line of code, as in the case of everything in WAMP, actually. RPC, so a callee registers an RPC. Again, that can be a prefix or it can be a full exact match. You're going to see later that in that invocation, I can actually tell the broker, or the dealer in this case, what is the load balancing strategy, because Bondy will do load balancing for you. So if I have 10 instances of a microservice offering you account create, then you can say, I want round robin. So every time somebody calls account create, Bondy will round robin across the 10. And there are different strategies that you can define. Again, registering, in this case, using round robin is as simple as this, right? So I have a function there called add, and now I'm publishing add. So now this function is available to be called by anybody connected to the network. So you got load balancing, and more important as well, there is no open ports on the server side, on the client side, which is really important for IoT. So we're not opening ports because everybody that participates in this network calls the router, opens a session with the router. It's not the router acting as an API gateway dispatching new TCP connections to your server. It's your server starting and saying, I'm going to offer this amount of connections, right, with the router, which is immediately, so it's more secure, but it's also a back pressure mechanism, right? And in any case, that is what the API gateway that you're using is doing, right? When you say, I'm using Kong or I'm using Nginx, Nginx is actually pulling all those TCP connections to your backend. So this is another way of doing it in which you are deciding how many connections you have in the pool, because it's every microservices, all the instances of your microservice deciding how many connections to offer. No external dependencies, no sidecars, no YAMLs. I can deploy this on bare metal with just one binary and a library on the application side. But we normally deploy these in Kubernetes as well, so you can deploy it anywhere. So let's do something in Erlang as well. So the Erlang client that we're using is not great, and this is due to the communication, but we're launching a new client now called Bondy Connect. Again, Bondy open source, client open source. So what I'm going to do here is, in Erlang, again, I'm going to call the market, right? And I will get everything that is on the market at the moment that we can see on the screen, right? But I can also register a new function in this network by doing just this one-liner. So this will take any argument. I will reply a list with echo and the argument that I pass. And now if I call it, I just went to Bondy, and Bondy called this same callee implementing the function, right? So it's as simple as that. So how is Bondy architected? And I'm going to try go quickly. So obviously this is written in Erlang. At the moment, the latest version is using OTP 26. The way we go about it is we don't allow you to choose which version. We decide which version, which is simpler. We don't use distributed Erlang. We use Partisan. And we started using Partisan since the beginning. And Partisan is a distributed Erlang replacement library created by Christopher Meiklejohn, who was doing his PhD using CRDTs. He was part of the Basher Technologies company, one of the creators of React KV. And basically what Partisan brings to the table is it allows you to move away from some of the limitations that you have in distributed Erlang. So in distributed Erlang, you have one single TCP connection between two nodes. That same TCP connection conflates control plane and user data, which might become a problem. So what Partisan does, it says, well, no, I'm going to have multiple connections. Actually, they're called channels. So we're going to have multiple name channels, and I can route traffic through a name channel. Name channels can have multiple connections inside as a pool, so I can shard across the different TCP connections on each one of the channels. But also, and crucially, Partisan allows you to design your own topology. So it comes with full mesh, and it also comes with Hyper-V. So full mesh was proven to scale better than Erlang, up to 200 nodes. And the Hyper-V implementation, Chris managed to get 2,000 nodes connected. In the last Elixir conference, someone presented Elixir Phoenix PubSub with Partisan scaling to 900 nodes in Amazon. So in order to reach that point, I had to fork Partisan and start working on it. And after doing a lot of work, I called Chris and said, listen, it's really embarrassing, the PR that I'm going to do, because it's a year's work that you haven't seen. And after that, he offered me to maintain Partisan, so I'm maintaining Partisan myself. So what we did in Partisan to support Bondy is that so Partisan didn't have support for OTP. So you couldn't do monitoring across nodes in Partisan. You couldn't do a gen server call across nodes. Now you can. So we have, basically what I did is I forked the OTP behavior implementations, and I changed, every time it says Erlang send, now it says Partisan send. Every time it says Erlang monitor, it says Partisan monitor now. Unfortunately, that doesn't work for all topologies. At the moment, it's only for full mesh. So below that, what we have is, and Partisan obviously manages the overlay network and the membership. It uses CRDT to disseminate the network view across all the cluster. So what you're going to see is that the Partisan nodes are constantly chatting, but they use a separate channel than the one that you are going to use to send your traffic, to basically maintain a view of that network. Below that, we store data in Bondy because, as I mentioned before, we wanted no dependencies. So Bondy stores realm information, users, permissions, using a role-based access control. And all that data is replicated across all the nodes. So everything that you write in one Bondy node is replicated to all the other nodes in two ways. using gossip, epidemic broadcast trees in real time. And we have an active anti-entropy mechanism that triggers a configured number of seconds that uses an on-disk Merkle tree to quickly compare the different nodes. So what we store there is we store in memory the routing table. So every time I say, for example, register this procedure or I'm subscribed to this topic, that information is in memory disseminated across the cluster. But on disk, we store the definitions of a realm, definitions of users, groups, and all the other objects involved as a control. So how a rooted RPC works, so every time, for example, we go here, or let's do it here. If I say, oh, my internet going down probably? Yes. Sorry. Let's carry on and see if I can get connected later on. So the RPC that we see, and every time I say click and I sell something, I call the com market add or sell item. What is happening is that I'm doing a call using WAMP, and there is a session on the Bondy side that handles all my communication. And Bondy realizes that I'm calling in this particular example, ComUp A list, and it knows that ComUp A list doesn't leave, so the session handling this function doesn't, or procedure doesn't live in this node, but lives in this other node. And because this is full mesh, there is only one hop for that call. If the session implementing the function was living in node N, then it would be a local call between the process handling my connection for client A and the process handling the connection for client B. Because client B is connected to another node, Bondy will relay that message. So every Bondy node acts as a relay for WAMP, right? So then I will target, send the WAMP invocation to client B, will reply hopefully with a yield or error, and then I will relay that back to the original caller, right? Now again, in full mesh, this is one hop, always. In Hyper-V is n hops, and in Hyper-V you have a partial mesh. Again, you can connect 2,000 nodes potentially, and we haven't tried yet with Bondy because we had to work on partisan to be able to do that, and we're very close to have that working. Now, the other thing that we added in last year is what we call bridge relay or Bondy edge. So the idea is, what if I want to run Bondy on a Raspberry Pi at an office, factory, or location, but I want all the RPCs that are happening and the topics being and the events happening there, or some of them being externalized and accessible outside of the factory. So the way you do that is you run a Bondy cluster in the cloud, as we were running right now on Fly, but then I can run another Bondy node on an edge device. This can be a cluster, by the way, so it doesn't need to be one Bondy, it can be another cluster, and one of them will create a bridge relay connection to the other cluster. And I will import and export RPCs and pops up. So now client A will call, and Bondy realizes this is not in this cluster, but this is located on an edge Bondy cluster. So it will relay one hop, if this is a full mesh, one hop to the other node that actually has a connection to the bridge relay, and then one hop to this other node, right? And it will come back. So very quickly, this is more or less what we cover. So WAMP offers a number of different authentication strategies: anonymous, cryptosign, ticket, which is basically a JWT or JOT, password authentication. We're just about to support Scrum, so we support CRA, and the way it works is we store hash of your password, so Bondy doesn't know your password. Cookie we haven't implemented yet, and we're not interested so far in implementing cookie, but we have trust, HTTP auth to password added on top. This is not part of the WAMP specification, but Bondy offers it. And we also have same sign-on and single sign-on. So basically, with same sign-on, I can have a single user, a single set of credentials accessing multiple realms. And if I combine that with ticket authentication, then I have single sign-on. I have, with a single ticket, I can connect to multiple realms. And everything is using source IP access control, so you can use CIDR masks to restrict who can connect using all of these different authentication mechanisms. Authorization, we have a full-blown role-based access control similar to Postgres, and we are hopefully implementing REBAC, which is a relationship-based access control based on a graph soon. Privacy, we've been playing with the idea of implementing E2E. There was a client of ours who was interested, but that never happened, and that's a very difficult topic to crack, given that something that I haven't mentioned is that everything in Bondy is designed to be eventually consistent. Now, that is, so we wanted Bondy to not rely on anything. And if I have a cluster of 10, 20, 40 Bondy nodes and 99% of them collapse, the one remaining still serving everything that can, right? But we're going to start building some form of consensus on top to be able to facilitate some other features, including end-to-end encryption. We support WebSockets and raw sockets. Quick would be nice to have. And the WAMP protocol allows you to serialize it. If you see the application here, you're going to see that this is plain JSON, right? So all these messages down here that we're receiving are serialized in JSON. So the protocol doesn't dictate a serialization when it comes to WebSocket, and in raw socket it has some binary header, but apart from that is whatever you choose. Going back here, so we support JSON message back. We're going to support Cyber. We also support BERT, which is very similar to Erlang, and we support Erlang. So if you have an Erlang microservice or service speaking to Bondy, you can choose to speak Erlang directly. It's a subset because you cannot send PIDs, you cannot send refs, right? But Bondy will take care of that. RPC features, you can obviously do calls, but you can cancel calls, you can time out on calls. There are other features that we implement in the WAMP specification. Caller identification, I can say, hey, you know, every time somebody calls me, I tell you who I am. Pattern-based registration, as we mentioned. Share registration, which means I can do round robin, load balancing. We implement the 4 load balancing strategies dictated by specification, but we added 2 more. So the queue list loaded takes care of the Erlang queue length. So it tries to choose the implementation with the lowest number of elements in the queue. We're just about to finish payload pass-through mode. That means that even though you've chosen JSON message back or something else to serialize the message, you want to use a different, an opaque binary as a payload, right? So for example, you can use protocol buffers inside a JSON message, or whatever you want to do, because it's a binary that then you need to interpret yourself. Bondy will not do anything with that binary. Next is progressive calls and progressive call results. So basically the idea is I want to download a very large video or image using RPC. So if I use progressive call results, I will get chunks and then in a file at the end, right? And same for PubSub. Most of the features implemented, but again, payload pass-through mode as in RPC. So again, and to finish, full mesh topology with one hop is what we have implemented. Next is Hyper-V topology. Bridge relay, we're just about to call that a release. Partisan offers retransmission or causal delivery. So we're using some of that in Bondy, but we want to improve the scalability of the backends that Partisan use to do that, and possibly in the future use causal reliable delivery. So WAMP doesn't offer any guarantees, so it's fire and forget in PubSub. And one idea would be to implement causal reliable delivery to guarantee that you're going to receive the message. Replication, again, global replication using eventual consistency. We use real-time gossip and periodic active anti-entropy. On top of that, we implemented a REST API gateway. Why? Because one of the first client that has been using Bondy for 5 years in production on an IoT platform. We have 500,000 cars connected, 2,000 alarm systems and video cameras connected, all the traffic going through Bondy. But the mobile application was written using an HTTP API, and they wanted to reuse that. So what we did is we basically created an API gateway within Bondy. So you give us a JSON very similar to an open API specification, but it goes a little bit beyond, because it's not only describing what the methods and the verbs and nouns in your API are, but it's also telling Bondy how this post / whatever converts itself into a WAMP call or a WAMP event. And you do that declaratively. You create that, you load that in a node that is replicated to all the nodes, and now you have a gateway in every node serving your API. We also have a broker bridge internally, so basically you can tap into any topic and say, send that to Kafka. And we're going to do RabbitMQ next. And the other option that we're looking into is implementing other protocols, because we think that WAMP is a common denominator. So if I add MQTT, if I add CoAP or Stomp, then all the integrations are facilitated. But then your developers can still use WAMP across all the existing ecosystems that you have. We're also planning to support external authentication. So basically, if you want to keep the authentication database outside of Bondy using Postgres or using a cloud server, you will be able to do that. So hopefully you've seen that WAMP can be used for the entire messaging requirements of a distributed application. The whole objective is to reduce accidental complexity. We've gone down from 3 or 4 middleware and I don't know how many protocols to a single one. And it offers a peer-to-peer programming model. So that opens up a new possibilities. So how about a web application calling another web application, or a server calling an RPC on a web application, or a web application calling an RPC on a device directly? And Bondy takes WAMP to the next level because it makes WAMP scalable. You can scale in and out, up or down. And we, with the other features that we're adding and with the vision that we have, we're trying to go way beyond WAMP into building, if you want, the distributed operating system. So there are more things to come, such as reliable workflows of WAMP functions and all kind of things that you can build once you have this core capability in place. So Bondy is open source, and our goal is to bring back the joy to distributed application programming. So check us out there. Basically, I need to thank everybody from my wife and children for tolerating all the weekends that I'm spending on parties and Bondy, but then the Lipside team, the customers that are currently using Bondy, but also the Erlang community. So some of them here, I'm using libraries of people sitting here. So Roxybee, Hackney, Cowboy, I don't know. Actually, and I wanted to do this. If you're here, thank you very much, because that is everything that we're using in Bondy at the moment.
Technology incredible.
Yeah. Cool. Thank you very much.
We are running out of time, but I guess we can have one question.
I'm sorry if I missed this, but payload security through Bondy?
Not yet. With payload pass-through mode, you could encrypt yourself, the payload, and resolve the encryption and encryption on your side. And for Bondy, that will be just a blob. what we wanted to do is to baking end-to-end encryption in Bondy. But the trouble is, how do you scale that? I mean, you can do, there are many ways of doing that with a limited set of clients, because you need to have a key group management, and it doesn't scale, right? So the idea would be to use some peer-to-peer encryption technology that scales and bake that into Bondy.
Okay, so the wire protocol is using just SSL, but the
SSL.
payloads, once it's within Bondy, is basically readable by anything that can receive it.
Exactly, unless you decide to use payload pass-through mode, in which case
Right, you can encrypt it yourself.
you can encrypt it yourself. And by the way, the specification for payload pass-through mode allows you to define all the metadata of the keys, you know, what keys are you using, what type of encryption are you using, so the other end will receive an event and will have the blob and the metadata to decide which keys to use and which.
So you can basically stuff it into a JWT,
You can say, yeah, exactly.
And then it's up to you.
Exactly.
Okay. Thank you.
Yeah.
All right, let's thanks Alejandro again.
Thank you.